Hello everyone. Today we will see one of the powerful tools in C language, the pointers. Before going to the details of pointers, we shall see how is data stored in computers and how to access its memory location. All the data in a computer, whether it be a program or data, are stored like ones and zeros, the bits. Group of bits are called bytes, that is group of 8 bits are called bytes, and a data may consist of a single bit, a number of bits, a single byte, or a number of bytes. Each of these bytes will have a particular allocated memory location. So all the data that we store in our system will have a particular memory location. In C language, we can use the ampersand operator for getting the address of that locations. The ampersand operator can be used to access the address of that particular locations. So in this example, we shall see how a value is stored in a system. So I have initialized a variable count equal to 100. So this 100 will be stored in a particular memory location, and this location can be accessed using the ampersand operator. So here I am printing the value of the count and address of the count. To print the value, we shall simply use the variable name allocated to that value. So count is the variable name, so simply using the name count we can print the value. We can use %d as a format specifier as it is a integer data type. And for displaying the address of the count, we are using the ampersand operator along with the variable name. So ampersand count will actually take the address of the variable. To display the address, we have to use the format specifier %p. %p format specifier is used for displaying pointer variables, the values of pointer variables. Actually, pointer variables contain the address of the variable. So to display these values, these hexadecimal values, we need to use the pointer data type specifier. So this is the address of the count 0x7FFC2B 7784BC. So this is a hexadecimal format, and this is the location where the value 100 is stored in my system. If you execute in your system, it will be a different value where the value 100 is stored. So this is the value, 100 is the value, and this is the memory location of that particular value. Pointers. The pointers are variables used to store address of another variable. Pointers are variables used to store address of another variable. This is a pointer declaration format. Data type star pointer variable. We shall see what are these. The first part, that is a data type, it refers to the type of variable that the pointer variable points to. So this is not the type of the pointer variable, because all pointer variables are of pointer data type. It actually refers to the type of variable that the pointer variable points to. That means if this pointer is used for pointing to a character data type, the data type will be written as char. The second part is an asterisk, a star symbol. This symbol is used to make a pointer variable. That is, it is used to denote that the pointer, the variable that we specify here is a pointer variable. And third part is the name of the pointer. Name of the pointer variable. So all pointer variables are of pointer type, and they can be used to point to any data type of variables. Any data type can be pointed to by the pointer variables. These are some of the examples: int star p and char star ptr. Here p is the pointer variable, star denotes that p is a pointer type variable, and this p can be used for pointing to an integer data type variable. The pointer p can be used to point to an integer data type variable. That is, p can be used for storing the address of an integer data type variable. Similarly, the ptr is a pointer variable which can be used to point to a character type variable. That is, ptr can be used for storing the address of a character variable. This is an example showing the declaration of a pointer, and using pointer we are going to print the value and address of a particular location. So I am taking the same example, count equal to 100. So 100 will be stored in a particular memory location. So to point to this variable, I am declaring a pointer variable p. So as count is of integer data type and p is used for pointing to this count, I have to use the same data type for p also. That is, the pointer variable must be declared as int because it is going to point to an integer data type. It is not necessary that we have to do it in the same line or write the pointer variable first. There is no such rules. We can have it in different lines or in the same line or in different orders. Anything is possible. So to assign the value, to assign the address of the value 100, to assign the address of the value 100, we have to use the ampersand operator along with count. So p is equal to ampersand count will store the address of count to p. So these two lines are the same lines that we have written in the previous example. Just by using the variable name, we are printing the value and the address. Count will display the value and ampersand count will display the address of that value. And we are using %p as the format specifier here. Next we will see how the pointer variable can be used for printing the value and the address. So a pointer variable is normally used for accessing the address of a particular location. So first we will see how the address is printed. So address can be printed simply by using the pointer variable name p and using the format specifier %p. So it will simply display the address of the variable. And for accessing the value of the value of that location, to print the value stored in that particular memory location, we will use star p, value of the count using pointers. So star operator can be used along with the pointer p to display the value. So once again, please note, if we are using the variable name can be used for printing the value of the count. Then ampersand operator along with the variable name will display its address. If we are using the pointer variable, the pointer variable name will print the address of that particular variable, and star p will display the value of the variable. So we can see the result here, the count and address of that count using the variable name as well as using the pointer variable. So p is equal to ampersand count, that is p holds the address of count, and now this p and ampersand count are having the same meaning. So it represents the memory location in which the count is stored. The value that is stored in the memory location is 100, and star p is having the same meaning as that of count. That is, star p also will represent the value that is stored in the memory location. This is an example showing the sum of two numbers using pointers. I have declared three variables, first, second and sum of integer data type, and I have used three pointer variables p, q and s for pointing to these three variables. So I am using p to point to first, q to point to second, s to point to sum. So I am scanning two variables first and second, and I am assigning the address of first and second to p and q respectively. Ampersand first will assign the value of, not the value, address of the variable first to p, then ampersand second will assign the address of the second variable to q, and ampersand sum will assign the address of sum to s. So if it was the addition using the variable names, we will write like sum is equal to first plus second. Here, as we use the pointer variable to find the sum, we are writing it as star s is equal to star p plus star q. Star p will hold the value of first, star q holds the value of second, and these two values are added and stored in the location specified by the pointer s. So after doing this, star s, that is sum, will have, star s refers to sum, sum will have the added value of first plus second. So by printing sum, we will get the sum of these two numbers. So to print sum, we can use a variable name, or we can also use star s. Instead of sum, we can also use star s to print the value. Here is the result, and the two number integers to add. The two numbers are 1 and 2, and this is the sum. Now let's see how pointers are used for accessing array and array elements. So the arrays can be accessed by pointers in different ways. One is accessing the different elements of the array, or accessing the entire array as such. So for that, I have initialized one array AR having 7 elements starting from 24 to -8, and I have used two pointer variables p1 and p2 to point to the array. So these two are used in different ways that I will discuss later. First, we shall discuss about p1. So p1 is a pointer variable which is declared in the same way as we have seen in the last example, just by putting star p1. So it can be used for pointing to a single element of the array. So initially I am going to point to the first element of the array, that is ampersand AR of 0. Ampersand of AR of 0 represents the first element of the array. So this is stored in P1. And one more method, we can have P1 is equal to AR instead of P1 is equal to ampersand of AR of 0. That is, the array name itself will point to the first element of the array. So it is written here. Array name itself is a pointer to the first element of the array. In the example, AR and AR of 0, ampersand AR of 0 are having the same meaning. AR and ampersand AR of 0 are having the same meaning. Both represents the address of AR of 0. So initially it will point to the first element of the array. So let's see how the different elements are accessed. So for accessing the different elements of the array using the pointer, we can simply increment the pointer. That is, incrementing the array pointer p1 will point to the next element of the array. So if I increment p1, it will point to AR of 1. That is, if I increment p1 just by one position, it will point to the next element of the array, that is AR of 1. The number of memory locations incremented depends on the data type of the array. That is, in this particular example, I have used integer data type. That means each of these elements will be taking 4 bytes to store the value. So if I increment, all these elements are using 4 bytes. So if I increment this pointer p1, it will actually increment by 4 bytes. It will increment by 4 bytes. So let's see how it is done. I am printing this using incrementing the pointers. So the initial condition I is equal to 0 for I less than 7. I plus plus, along with this I plus plus, I have incremented one more thing, that is the pointer variable, just by writing p1 plus plus. Even though p1 plus plus represents p1 plus 1, it is not incremented by just a single digit 1. It is actually incrementing the pointer variable by 4 bytes. So the location will be incremented by 4 bytes in this particular case, as it is integer. So it is printing address of AR of %d. To index it, I am using this %d. So first it will print AR of 0 equal to %d. So this is the value, and that value is represented using star p1. So initially it is pointing to AR of 0. So initially it will print the value of AR of 0, that is 24. So address of AR of 0 equal to 24 is this one. So this is a address of AR of 0, and that address is simply printed using p1. So note that p1 must be of what type? Percentage %p type to represent the pointer. So after this operation, this increment operation will be done. I will be incremented to 1, and by doing this p1 plus plus, you can see here this is incremented by 4 locations. So in the next iteration, it will print address of AR of 1 is equal to the second value, that is 3, and you can see here the address is actually incremented by 4 locations. This 80 plus 4 is equal to 84, and this process is continued, and you can see in each iteration it is printing the next value along with the next address. That is, each time it is incremented, it is incrementing the value by 4. Please note all these additions are in hexadecimal. So accessing the individual elements using the pointer is shown now. Now we will see how the entire array can be accessed using the pointer. That is, to point to the entire array, we can use a pointer. That means it will point to the whole locations of the array. The whole location of the array means it will be 1, 2, 3, 4, 5, 6, 7. 7 into 4 bytes. That means the pointer p2 is used for pointing to the beginning of a bundle of location of 28. So the total number of bytes in the location is bytes in the memory is 28, and p2 is pointing to these many locations. Actually it is pointing to the first location, but if I increment p2, it will increment the location by 28 bytes. So the format is like this: star p2 within brackets, and after that an opening and closing square bracket within which we represents the number of elements of the array. So here the array is of 7 elements, so star p2 of 7. So this simply represents 7 into 4, that is equal to 28 locations. So it will point to the beginning of these 28 bytes. Actually this also will point to the first element of the array. So you can see here address stored in p2 is printed in this line, and this is same as this value. So p1 was initially pointing to the first element, now p2 is also pointing to the same element. But if I increment the address p2 by 1 location, that is if I do p2 plus plus or p2 plus 1, it is actually incrementing the location to the first location value plus 28. So this is equal to 9. So it is skipping 28 locations. So it is taking 28 locations, and so it is printing the location after these 28 locations. So if you add 28 to this 80, 282, this 80, you'll get this value in hexadecimal. So to point to an entire array, declaration is done as star pointer name array size. So in the above example, star p2 of 7, that is p2 will point to the whole locations of array of 7 elements of 4 bytes equal to 28 bytes. Now we will see the pass by reference effect. So to represent the pass by reference effect, we are using the example of swapping two values. Swapping two values means if two variables a and b are having the values 100 and 200, after swapping, a will hold the value of b and b will hold the value of a. So after swapping, a will be equal to 200 and b will be equal to 100. So pass by reference effect, to show pass by reference effect, we are using the functions in which the parameters are pointers. We are passing the references, not the values. So in previous chapters we have seen passing the values to functions, but in this case we are not passing the values as such. We are just passing the address of that variables. So in this example, two variables are there, a and b, holding the value 100 and 200, and the pointers to point to a and b are p1 and p2. So p1 is given the address of a and p2 is given the address of b. Now it is just printing the address stored in p1 and address stored in p2. Address of a equal to p1 and address of b equal to p2. So this is displayed here. Address stored in p1, that is address of a equal to this value, and address stored in p2 equal to address of b equal to this value. These two are two different memory locations of 4 bytes. So the meaning is a is stored in this location and b is stored in this location. Now it is printing the values of a and b before swapping is done by using the variable names a and b. So it is printing the value of a and b. You can see a is equal to 100 and b is equal to 200. Now to swap, I am passing the pointer variables p1 and p2 to the function swap values. So this is a user defined function swap values, and which is defined here. So to swap, I am passing the pointer variables p1 and p2, and note that this is a function which is having a return type void, that is, it is returning nothing, but it will do the operations as we wish. We wish to actually swap the values, but it is not returning any value back to the main function. But even after not returning anything, it can display the swapped values, because p1 and p2 are the memory locations, and these locations are passed to the function. So any operations performed in the values of these memory locations will be affected here also. That means anything that we do inside the function will reflect in the main function. So if I change the value stored at p1 in the main program, also it will reflect. Similarly for p2. So I am going to change the value stored at P1 and P2 inside this subfunction swap values. So while defining the swap values, what I have to do, I have to give the parameters as pointer type. So int star ptr1 and int star ptr2. So this int is not the type of the pointer, it is pointing to an integer data because a and b are integer datas. This p1 and p2 are address of a and b. So as a and b are integer type, in the definition we have to use int. I am using a temporary variable temp to hold one of the data temporarily. So temp is equal to star ptr1. Now star ptr1 represents the first value 100. So 100 is stored in temp. Star ptr1 means 100 is stored in temp. Next, star ptr1 is equal to star ptr2. Now I am going to store the second value that is 200 using star ptr2 to star ptr1. That means I am storing the value 200 to the location of ptr1. So location of ptr1 means location p1. Location ptr1 means location p1 itself. So p1 will hold the location p1 will hold the value 200 now. After this operation, this will hold the value 200. And after this, I am going to save the value, that is the value 100 that was stored in the previous step, using temp back to the second pointer location. That is ptr2 is actually holding the location p2, which is the location of b. So now after this operation, b will hold the value 100, and through this operation a will hold the value 200 also. That means after the swap operation, a will hold 200 and b will hold 100. So nothing is returned back here. You can see from the function also I am displaying the address stored in ptr1. That is, address stored in ptr1 is address of a itself. Address stored in ptr1 is equal to address of a itself, which is same. From the function also I am displaying the address stored in ptr1 and address stored in ptr2, which is the address of b. These two values are same. So here nothing is returned back because p1 represents ptr1 itself, p2 represents ptr2 itself. Actually the locations are passed to the functions. So any change made inside the function will definitely reflect in the main function also. So I have changed the value in the first location and second location, that is actually swapped the value stored in the first and second locations. So after the operation, a will be equal to 200 and b will be equal to 100. So you can see here, before swap the value is 100, the value of A is 100, stored at location 28, stored at location 0x7ffd29 CAB28. That is, it represents the location of A, P1, and 200 holding the value of B, and the location is this, location of B equal to P2. And you can see after swap, just the values are changed. Thanks for watching, and if you have any doubts, please ask in the comment box below. Thank you.